Hello and welcome to this animation nodes tutorial. My name is Frederik Steinmetz and today we'll have a look at how to use a track 2 with the animation nodes. These eyes here, as you could see in the preview, are tracked to the camera. So if I move the camera around, the eyes will follow, unless of course I have the auto execution off. Set this to always, and now they do. Okay, I think if you look at this from above, you can see it much better. Now, wherever I move the camera, the eyes are looking at the camera. And the setup for this is fairly simple. I have it right here. And let's go ahead and recreate that from scratch. Alright, here we have the eyes and the jar. I'm going to hide all the unnecessary stuff. And let's go to this texture so we can see where the eyes are looking. Alright. We have an empty node tree at the moment, and let's create the animation for one eye first, and then we're going to create a loop which will then copy that constraint, let's just call it a constraint, to all the other eyes. Alright. The first thing we need is a transform output. Transform output does transformations to the object. And if I click the little eyedropper here, I get the active object, which is the eyeball morph and .002, and it's being filled in here. If I want to do anything to the rotation, I need to tick those boxes. And as you can see, if I now change these values, you can see the eyeball rotates. You can see I have my tree at auto execution, but I unticked always. You only need always when you do something in the viewport, as we saw earlier. If I move the camera around, the node tree doesn't realize that. So I leave this at tree changed, which means if I insert a node or make a new connection, frame changed, meaning going back and forth with my arrow keys or pressing Alt A. Property changed, if I change any property of any node, this will cause the tree to update. Alright, so this here shows we're on the right track. We need to manipulate the object transform outputs, but how? For that, I'm going to insert a vector, and we can actually do a direction to rotation. But you can see there's a lot of stuff in the vector math already. And if you use, let's just insert a vector, some sort of vector. You can see they are dark blue, while this is more of a very dark blue. So if I combine these, you can see there is actually a direction to rotation method, or a conversion node being inserted for us. And this means even though this here is a vector consisting of an XYZ, it is not the same type of vector as this one. It is an Euler vector. And this is why the direction to rotation node is under rotation. And you can see both those lists are pretty full, so it's a good idea to actually split them. So I got this node. If you don't want to insert it the way I did, actually I did this accidentally, you can find it under rotation and direction to rotation, and you can always press Ctrl A, and then if you know the name of the node, you can just type it in and insert it. Since the list here is growing and growing, this is actually a preferred method often. Alright, so we need the direction and the guide. The guide is actually the object that we want to transform in our case. So let's get a object transform input. My list is actually getting transform input. There it is. Alright, let's click the eyedropper again, and we'll use the location as the guide. Next thing we need, do the same thing, but this time we'll select the camera and the location is the direction. Alright, something happened. So if I rotate the eye and then execute the node tree, you can see something happen, but the eye is not looking at the camera. So if I choose local here and activate my widget, you can see the eye is looking in the X direction. And the track 2 is basically the Z direction. So if we convert this from X to Z, you can see the eye is now looking at the camera. So you need the axis that it's in pointing in now, and then the axis which it's supposed to point towards, which is, I think it's always Z. Don't quote me on that, but if you're unsure, just keep clicking these until it works. Alright. Now, that worked fine. We now have one eye looking at the camera. That's great. But we want the animation started by each eye looking in a random direction. So let's choose a rotation and a random Euler. I choose random Euler here. You can see this is just producing some sort of random rotation, and I want the full 360 degrees, so I'm going to type in pi times 2, which is 360 degrees in radians. Alright, 6.28, meaning pretty much everything's possible. Now we need to mix these, because at a certain point I want them to transition from the random rotation into the set rotation, which is this one. So again, rotation, Euler mix. Now this connected it to the factor, which is of course not what I want. I want this to be here and this to be here. And the factor, you can see, actually goes beyond 1. So let's clamp the factor. Okay, so you can see if I change the factor, this gets interpolated. Once the factor is above 0, the eye starts to rotate away from the camera. So let's flip these, because I want the eye at 0. I want which is basically the start frame, I want the eye looking at random direction, looking in a random direction, and at frame X I want the factor to be 1 or above 1, and it'll be looking at the camera. So the Euler mix here, that works great. It's exactly what I want. Now let's do that for all our objects. And if you want to repeat something for a certain list of objects, you need of course the list of objects, and also you need a loop. So I'll press Shift A, and under subprograms I'm going to create a new loop. New loop looks like this. Right now it has an iterator, which is the index, so the loop doesn't know how often to repeat itself, and well, at the moment it doesn't even know what to do. So what we're going to do is an iterator. You can see all the iterators are lists, which means the loop will go through a list as often as there are elements in the list. So I'm going to choose object and object list. Now our loop can get the input of an object list, or so if we manage to group some objects, put them into a list, we can feed them into our loop. And the way to do that is under subprogram again. Now that my loop exists, if you open subprograms, you can see it's appearing here. So if we call this eye rotation and invoke the subprograms, now we have the eye rotation, or rotation. And you can see, since we added the iterator object list, you can see there's an input for an object list now. You can see that all these eyes are green, meaning they all belong to a list or a group, and the group is called eyes. If you don't know how to do that, you just select all the objects, press Ctrl G, and then type in the name of the group here. That I brought that up using the F6 menu, the T menu. F6 brings it up as a pop-up. Alright. So now they're all in a group, and we can choose a object group from group. We can just choose the eyes here and feed it to the object list. Okay, now our loop, there's 12 objects selected, which means we have 6 eyes because each eye also has a pupil here. We can ignore that though. Okay, so 6 eyes. Now the loop is going to be executed 6 times. And to prove or to test, let's say, that actually our loop is executed on all eyes, we're just going to change the object, which is a static object at the moment, to all the objects in the group. Now you can see the factor is at 1, so put this at 0, and basically nothing happens. Unless, except of course for the original eye. So why is that? Because the transform output are only applied to the original eye. It calculates the rotation for all the eyes, but it only applies them for the last one. So if we want to do this for all of them, we need to also tell it to do it to all of them. Alright, let's change this factor, and you can see they're all rotating in a random direction, but it's always the same random direction. So it is truly random. We can double check that by using the seed, but it's all uniform. The reason for that is, as long as you use the same seed for any node in the animation nodes, it'll calculate the same number. And that is very handy if you're doing multiple things at multiple times, and also it is crucial because otherwise if you'd go back a frame, if all the numbers changed, that would be a huge problem. Alright, let's connect the index of the object, which is basically object 0, object 1, object 2, and so on, to the seed. And that means we generate a different random value each time we run through the loop. If you don't like this constellation, you can change the node seed. I like this part, I like this way. Okay, so now all the eyes look in a different direction, random direction. If we animate the factor up to 1, they all look at the camera. Let's look at the camera. So they all look at us if we change the factor to 1. Alright. One thing you may have noticed is the only node that's not pink is this one. And that means all the other nodes belong to this loop. And that's kind of important as soon as I want to introduce values that don't need to be in the group or in the loop. Alright, let's do that. Animation time info, which outputs the current frame. If I use this as a factor, of course it's going to be 1 from the beginning. This is 0, so the factor is 0, and this is 1, so it's already at full track to rotation, let's call it that way. So we can now see that by connecting it this way, it also turned purple. If I disconnect it, it turns gray again. And that means that right now the frame is going to be, let's say, asked. It's called, the frame node is called each time the loop gets executed. And that means 6 times per frame we check what time the frame is. And that's not too clever. It doesn't really matter in our case because checking for a float 6 times, that's nothing. But it can get more complex, and also you might need the frame node for more stuff, and then you need to call it, I don't know, just very often. Let's just skip to the part where I tell you how it should be done and not stutter about how it's might be a bad case. Right, let's just disconnect this and choose a new parameter. The new parameter is a float, and now if we go down here, we can see in our subprogram invocation there's a float now. Connect the time, and this does the same thing, except we only need to call the time parameter once. And we can now connect this. And frame 0 that way, frame, and so on. Okay, so next thing I want to do is I don't want this to be 0 or 100%. I want this to evolve. So we'll just divide the frame number by, let's say, 10. And this way, in the course of 10 frames, you see the eyeballs rotating towards the camera. So that's nice. And before you start posting YouTube comments that this is not the best method, stay tuned, we're going to change that. But first, something else. I have the basis and the rotten shape keys. So if I turn this shape key, the eye mutates towards a rotten eye. And you can see how I did that in the previous part. But let's have a look at how to combine these animations. Of course, for that we need a shape key and shape key node. We need a shape key from object. And once we choose an object, nothing really happens because the node kind of works in secret. But since we see the shape keys here, we can see this is number 0 and this is number 1. Then we need a, let's search this again. We need a shape key output. And you can see again, I can choose a shape key on an object, or even better, I'll feed this the shape key, but you can see this is shape keys with an S, this is shape key. So if I combine this, a list, get list element will pop up, and I need the first one. 0th one would be the basis. Alright, so in the new node system, you can often see a little dot here, and that means oftentimes your node might not do something, and that is because the dot is not checked. So right now, if we actually want to change something with the shape key, we need to check the little dot. And now you can see this is going at the same time. Okay, great. So same thing again. I don't want to do this only for this eyeball. I want to do this for all the eyeballs. So all I need to do is connect this here, and you can see does this for all the eyeballs at the same time. And while we're at it, we can use the same factor as a value. Okay, now if let's make a timeline out of this. Zoom in, and if I scrub through the timeline, you can see they are morphing and they are spinning. Okay, great. That is what I wanted. By increasing this number here, I can make the animation last longer. So this is the duration. And of course, if I wanted to start this earlier, I could then add a subtract node before the math node and then clamp the result. But that's not the proper way to do this. I'm going to press Ctrl X, but that doesn't work with the animation nodes too well because there's just so many different types of node sockets. So we're just going to have to connect this manually, and we can just use a map range, which is right here. Alright, I'm going to drag this in between. Now this looks a bit intimidating maybe, or a bit confusing. All I see is numbers. But what this does is interpolate between two ranges. So if I set the input minimum to 0 and the input maximum to 1, this wouldn't change a thing, because 0 gets mapped to 0, 1 gets mapped to 1, and so on. But if I want 20 frames, and now we output 0 to 1. So that does exactly the same as dividing it by 20. So 0 gets mapped to 0, and then 1 gets mapped to 1/20th, if that makes sense. We do want the output min and max stay 0 and 1 because we're using it as a factor between 0 and 1. But we can choose what frame range we want to map to this. So this is actually pretty elegant. If I change this to 20 and this to 40, now we still have a duration of 20 frames, but we start at 20 because the numbers between 40 and 20 will be mapped to 0 and 1. Anything below 20 will also be mapped to 0, and anything above 40 will also be mapped to 1. So we don't need to worry about clamping, we don't need to worry about different subtract and so on method, and the best part is we can even use an interpolation, meaning we can choose from a lot of different methods. I'm going to go with quadratic and choose this one. That means it's starting slow but then becoming fast. Alright, that's it for this part. You can see you can always, I kind of like cleaning up nodes. It's fun if they look really nice at the end before I save this. And by cleaning up I just mean move them around. Anyways, that's the node tree. That's it for this tutorial. Thank you for watching. And as always, please do try this at home.